Yes, there are underground connection or tap boxes available for larger electrical services like a 3000 amps 208 volts three-phase service. These boxes are typically made of durable materials such as concrete or fiberglass. They are designed to withstand environmental elements and provide a secure connection point. One type of underground connection or tap box is a handhole. Handholes are typically cylindrical or rectangular in shape and have a removable cover that allows access to the electrical connections inside. They are installed underground with the top of the box flush with the ground level. Another type of underground connection or tap box is a vault. Vaults are larger than handholes and are typically used for larger electrical services. They are installed underground and have a door or hatch that provides access to the electrical connections inside. When selecting an underground connection or tap box, it is important to consider the following factors. Firstly, service size. The box must be large enough to accommodate the conductors and connections for the electrical service. Secondly, location. The box must be located in a convenient location that is accessible for maintenance and repair. And thirdly, code requirements. The box must meet all applicable electrical codes and standards. Once the underground connection or tap box is installed, the utility conductors and the building service conductors can be connected inside the box. The metering can then be fed from the connections inside the box. Underground connection or tap boxes are a safe and effective way to provide a connection point for electrical services in situations where there is no room for a connection or tap box on the wall of the building. It is important to ensure that the underground connection or tap box complies with all relevant electrical codes and standards, such as those outlined by the National Electrical Code, or NEC. Consulting with a qualified electrical engineer or contractor is crucial to ensure proper selection, installation, and maintenance of the underground connection or tap box. Several factors must be evaluated during the selection process. Firstly, consider the size of the electrical service. The underground connection or tap box must be adequately sized to accommodate the conductors and connections for the electrical service. This includes considering the current carrying capacity of the conductors, the number of conductors, and the size of the connections. Secondly, evaluate the location. The underground connection or tap box must be located in a convenient location that is accessible for maintenance and repair. This includes considering the depth of the box, the accessibility of the box, and the potential for flooding or other environmental hazards. Thirdly, verify code requirements. The underground connection or tap box must meet all applicable electrical codes and standards. This includes considering the requirements of the NEC as well as any local codes or regulations. The NEC provides specific guidelines for the installation of underground electrical systems, including the type of enclosures, the depth of burial, and the type of wiring methods that are permitted. Proper installation of an underground connection or tap box involves several steps. Firstly, excavate the site. The excavation must be large enough to accommodate the box and any necessary backfilling. Secondly, install the box. The box must be installed according to the manufacturer's instructions and all applicable codes and standards. Thirdly, connect the conductors. The conductors must be connected according to the manufacturer's instructions and all applicable codes and standards. Fourthly, backfill the excavation. The excavation must be backfilled with a suitable material that will not damage the box or the conductors. Regular maintenance is essential to ensure the continued safe and reliable operation of an underground connection or tap box. This includes inspecting the box for damage, checking the connections for corrosion, and testing the insulation of the conductors. Proper grounding is also essential for electrical safety. The underground connection or tap box must be properly grounded to prevent electrical shock hazards. The NEC provides specific requirements for grounding electrical systems, including the size of the grounding conductors and the location of the grounding electrodes. In addition to handholes and vaults, other types of underground connection or tap boxes are available, such as pad-mounted transformers and submersible enclosures. Pad-mounted transformers are typically used for larger electrical services and are installed on a concrete pad. Submersible enclosures are designed to be completely submerged in water and are typically used for applications such as street lighting and irrigation systems. The selection of the appropriate type of underground connection or tap box depends on the specific application and the requirements of the electrical service. Careful consideration of all relevant factors is essential to ensure safe and reliable installation. When working with electrical systems, it is important to follow all safety precautions. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and energizing the electrical system before working on it. Only qualified electricians should perform electrical work. Improper installation or maintenance of electrical systems can result in electrical shock, fire, or other hazards. Proper planning is critical. Before installing an underground connection or tap box, it's crucial to have a well-defined plan that considers all the relevant factors. This includes the size of the electrical service, the location of the box, the code requirements, and the available space. A detailed plan will help to ensure that the installation is performed safely and efficiently. Understanding conductor ampacity is also crucial. The ampacity of a conductor is the maximum amount of current that it can safely carry. The NEC provides tables that list the ampacity of different types of conductors based on their size, insulation, and temperature rating. It is important to select conductors with an ampacity that is sufficient for the electrical service. Overloaded conductors can overheat and cause a fire. Regarding overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical systems from overloads and short circuits. These devices are designed to trip or blow when the current exceeds a certain level, interrupting the flow of electricity and preventing damage to the electrical system. The NEC provides specific requirements for the size and type of overcurrent protection devices that are required for different types of electrical circuits. Surge protection is also important. Electrical surges are brief, high-voltage spikes that can damage or destroy electronic equipment. Surge protection devices are designed to protect electrical systems from surges by diverting the surge current to ground. Surge protection devices are available in a variety of types and sizes, and it is important to select a device that is appropriate for the specific application. When choosing an underground connection or tap box, consider the environmental conditions. Underground electrical systems are exposed to a variety of environmental conditions such as moisture, temperature extremes, and corrosive soils. It is important to select a box that is designed to withstand these conditions. Boxes made of concrete or fiberglass are typically more durable and resistant to corrosion than boxes made of metal. Soil conditions also matter. The type of soil in which the underground connection or tap box is installed can also affect its performance. Some soils are more corrosive than others, and some soils may contain chemicals that can damage the box or the conductors. It is important to select a box that is compatible with the soil conditions. Consider cable types as well. Several different types of cables can be used for underground electrical systems, such as direct burial cable, conduit cable, and armored cable. Each type of cable has its own advantages and disadvantages, and it is important to select a cable that is appropriate for the specific application. Direct burial cable is designed to be buried directly in the ground without any additional protection. Conduit cable is installed in a conduit, which provides mechanical protection for the cable. Armored cable is protected by a metal sheath, which provides both mechanical and electrical protection. Consider the depth of burial. The depth at which the underground connection or tap box is buried is also important. The NEC provides specific requirements for the depth of burial of underground electrical systems. The depth of burial depends on the type of cable, the voltage of the circuit, and the location of the system. It is important to bury the box at the correct depth to protect the cable from damage and to prevent electrical hazards. Also consider accessibility. While underground connection or tap boxes are designed to be buried, they still need to be accessible for maintenance and repair. It is important to locate the box in a location where it can be easily accessed. This may involve installing a handhole or a vault to provide access to the box. Also remember to mark the location. It is also important to mark the location of the underground connection or tap box so that it can be easily located in the future. This can be done by installing a marker post or a sign near the box. The marker should clearly indicate the location of the box and the voltage of the electrical system. Also consider future expansion. When installing an underground connection or tap box, it is important to consider the potential for future expansion. If there is a possibility that the electrical service will need to be upgraded in the future, it is important to select a box that is large enough to accommodate the additional conductors and connections. Consider the load calculations. Accurate load calculations are essential for designing a safe and reliable electrical system. Load calculations involve determining the total amount of power that will be used by the electrical system. This information is used to select the appropriate size of conductors, overcurrent protection devices, and transformers. The NEC provides specific guidelines for performing load calculations. Review NEC Table 310.15b16 for ampacities of insulated conductors rated up to and including 2000 volts with not more than 3 current carrying conductors in raceway or cable or earth based on ambient temperature of 30 degrees Celsius and so forth. Also remember to torque connections properly. Proper torquing of electrical connections is essential to ensure a safe and reliable connection. Over-torquing a connection can damage the conductor or the connector, while under-torquing a connection can result in a loose connection that can overheat and cause a fire. It is important to use a torque wrench to tighten electrical connections to the manufacturer's specified torque. Also remember to test the installation after installation. After the underground connection or tap box has been installed, it is important to test the installation to ensure that it is working properly. This includes testing the insulation of the conductors, checking the grounding system, and verifying that the overcurrent protection devices are functioning correctly. Also remember documentation and record keeping. Proper documentation and record keeping are essential for maintaining a safe and reliable electrical system. This includes keeping records of the installation, maintenance, and testing of the underground connection or tap box. These records should be kept in a safe place and should be readily available for future reference. Furthermore, consider cathodic protection. Cathodic protection is a technique used to protect underground metal structures from corrosion. It involves applying a small electrical current to the metal structure, which helps to prevent corrosion. Cathodic protection is often used to protect underground pipelines and tanks, and it can also be used to protect underground connection or tap boxes. Proper coordination is key. Coordinating with the local utility company is essential when installing an underground connection or tap box. The utility company will need to approve the installation and will need to make the final connection to the electrical grid. It is important to work closely with the utility company to ensure that the installation is performed safely and correctly. Remember ongoing maintenance. Regular maintenance is essential to ensure the continued safe and reliable operation of an underground connection or tap box. This includes inspecting the box for damage, checking the connections for corrosion, and testing the insulation of the conductors. It is also important to keep the area around the box clear of debris and vegetation. Remember that safety is paramount. Working with electricity can be dangerous, and it is important to follow all safety precautions. Only qualified electricians should perform electrical work. Improper installation or maintenance of electrical systems can result in electrical shock, fire, or other hazards. And finally, remember to stay informed. The electrical industry is constantly evolving, and it is important to stay informed of the latest codes, standards, and technologies. This can be done by attending industry conferences, reading trade publications, and taking continuing education courses.